So I just want to go over some things that I've done recently and point out a few important aspects of this stage in making a coffin plane. So let me start with one thing here. What I did was I went ahead and I machined everything down this ramp all the way down, and I got it as close as I could with my tools. And then what I did was I cut a very long strip of 150 grit, exactly the width of my blade. I used my steel that I have, and I placed it over the sandpaper. I clamped it on both ends, and I used it to sand this area through here to make it flat. And I kept checking it. The goal is to make it flat so that when the wedge engages the blade, that it locks it in there and you prevent chatter. The other thing is that if it's uneven, you will have a space, and this blade, even on a very, I would almost call it like a microscopic level, when this blade is in here and you hone the edge and you're passing it over another piece of wood and using it, this blade might chatter a little bit. So you want full contact on this bed right along here and all the way up the ramp. So I did my best to achieve that. The other thing that you want to look out for when you're at this stage is you don't want this blade to rock. That's also a signal. So you're looking at it visually, how it lays on the ramp, and you're also looking to make sure that it doesn't rock. Now, the same way that it rests on the bed back here, you also can use the blade to check the buttress for the wedges, or the wedge. So that's also your signal that all the angles in here are true to each other, because you're going to cut your wedge with both sides parallel to each other, like this. They're not going to be like this or like this, and they're not going to be like this. They're going to be square to the center line of the plane, the edges of the theoretical sides of the plane. So all this in here has to be straight, square, and level to each other, so that you don't have one side of the wedge engaging the buttress before it hits the other. Now you can tune the wedge later, but the idea is to get everything really close in the body of the plane first. So another thing about the buttresses, let me see if I could illustrate this with a wooden stick. What I do here is this is all a 1/4 inch away from the side of the plane body until it gets down to here, which is really the end of this throat area. So right here, from here all the way to the bottom of the plane, which, let's see if I illustrate it using the drawing, the buttress stays a 1/4 inch thick till about right here, and then it tapers to 0. And the reason it tapers to 0 is to give the chip the biggest area to come off the edge of the blade, and then it funnels along the tapered part of the wedge and through this throat area as it starts to curl. And that's your clearance. You need, as you're creating that chip way down in here, you need clearance. And so that's the point where the full width of the wedge ends and the taper begins. And that taper is also important because it has to extend as far as possible down to the cutting edge of the blade in order to prevent that chatter, because there's a lot going on right at that edge, almost to a microscopic level, because you're honing that edge to You know, you're using very fine stones, you're polishing it, you're doing everything you can to make it as sharp as you can. You cannot have a deflection that's greater than your ability to sharpen it. Otherwise, you're moving backwards, and you're not going to create a good finish in your work when you use the plane. This is going to be a working plane. So this is how you build precision into a wooden plane, even though we're copying an antique. This design is well over 100 years old, but what we're doing is going to make it perform like it's a world-class plane, or virtually a world-class plane. It's probably never going to compete against a steel-bodied plane, but it'll do a heck of a job, and it'll be handmade. So, and then what also I did was, let's see if we could see here. So you have this area where it's 1/4 of an inch away from the body of the plane, and then what it does is, as right where that taper starts, then it converges back to where it needs to be in the design. So once I do the final shaping all in here and everything, then what I'll do is I think I even drew it in on here. No, I didn't. I drew it in on the other one. So this is what I call my little scoop detail. So I'll do that with a file or a gouge, and I'll take all that away, and then I'll dress up all this with sandpaper. And the other thing that you need to do is in this throat area in here. Let's see, this area right here. This needs to be straight. It needs to be flat. It should be parallel to the blade, which is a good way to sight it, is right through here. So you could see the line of this edge, which represents where the blade is resting, and then the line further back through the slot, back up in here. That's your escape area for the chip. They should be parallel to each other. And then this whole area right here where that chip is going to develop, that needs to be flat and it needs to be smooth. And I apply paste wax to this area so that as the chip grows and starts to curl, there's a reduced area of friction back in here, because otherwise they'll curl up and they'll jam. So just to review, got to keep this area flat, keep this area on inside the buttress flat. You need full clearance in here for the blade material, for the wedge. Everything should be square, parallel. Then you're going to converge all your lines through here. Keep the throat dressed up very nicely. It's not a whole lot of work, but you should be careful because your handwork with all this mortising is going to affect how the plane performs. So let me just go over what I did. I cut the blade stock to length. I took a little 3/8 by 3/8 corner off the blade just to dress it up a little bit. All this work I did with the hacksaw because I didn't want to go outside in the rain and make noise and disturb my neighbors. So that's all done with handwork. I'm going to file this up, touch it with some diamond stones, get it dressed up. I'll basically make it look like the factory edge. Just continue it around the sides. Then here, I filmed myself putting the two torches on the edge. Normally what I do on all my blades is I just heat up the end. This will give me about, I'm going to say about 20 years worth of sharpening right through here, like the first 1/2 inch. If I find that the blade is not holding an edge in 20 or 30 years from now, I'll put it under some more heat and harden it again. I'm not too worried about it. I don't have a forge. I don't have a heavy-duty operation. So I get as much heat as I can with 2 torches. I've done it with 3 torches as well. I've done it with 3 torches when I wasn't filming. There's just too much to do with the camera on to be working with 3 torches. So I think I accomplished what I wanted. And so what I do is I use canola oil. I reuse the oil. I have a can that I dunk the blade in, and I have a container that I store the oil in, and I keep reusing it. It's been working out fine. So far I've been doing that about 4 or 5 years. So this will all come off. I usually take this to the sink and do it with dish soap and get a lot of this stuff off. This is the heated up oil. It's all like carbonized and stuff. So I get all this off in the sink. I'll use a scrub pad or whatever, dish soap, and then I'll start with the diamond stones and I'll get what's ever left off of it. And then I'll take it out to the grinder. I have a rough 25-degree bevel on here. I don't know if you can see that. It's pretty square. But after I clean it up, I'll probably take it to the grinder one more time. Just put a fresh face on this. And then I'll start with the stones. And back here, like I said, I'll dress this up with files and diamond stones and get this all equal, balanced out, these 2 cuts. See how this thing works. I got the wedge fitted a little bit. Should be close. Blade sharpened. It's already shaped and all. I roughed out the plane on the compound miter box. The throat is nearly done. Got most of my shaping done. So let's see. Let's give it a spin. I took the blade to 1200 on my sharpening stone. There's a little crown right in this plank. I don't feel too much chatter. In fact, I don't feel any. So let me do a close-up on this. This wedge has not been fitted, along with the abutments in here. So what you're looking for is a let's see if I can get this. I don't know if you can see it too well, but right in here you want this to be really tight on both sides. You can't see it. All in here, all through here. This has to be tight all the way down. The idea is that when this wedge goes in, it locks up continuously. You cannot have a high spot. You can't make contact in one area first, because what will happen is you'll have another area, like let's say there was a high spot in the front, so it'll lock up in the front, and then this back will still be loose. You don't want that because the blade will move. And if it's the reverse, where it locks up back here and it's loose in the front, then you'll have chatter. You won't have a smooth cut. So it affects the cut. The fit of the wedge affects the cut, and it also affects how you set the blade, because you don't want the blade to be difficult to set, and you don't want it to come loose. And you also want it to be where a nice hit with your hammer in the back of the plane will loosen the blade. There's a lot going on there, but this one I got in the first shot. The other one had to be tuned, but it's not a big deal. And what I see is there's a lot of jamming in here, which is not the end of the world. These are not really coming out as long shavings because I'm surface planing, but I bet on an edge that would work out real well. So I got more shaping to do. I'm going to go ahead and do the other wedge. Let me just show everybody what the end of this wedge looks like. This is it right here. So this is not the zero of the wedge that I cut. There's about 1/4 of an inch taken off. The reason why is because if you leave the full length of the wedge down to a point, it'll actually pass through the bottom of the plane, and you don't want that to happen. So you got to cut off about 1/4 of an inch, 3/16, whatever. And then what I did was I shaped these tapered parts are the same place on the abutment where they taper in, and then I just added an equal amount back to here, and then I scooped all this in with the I don't know if you could see that, but then I just shaved all this in with the plane maker's float and some of the rasps that I had. And you keep the 1/4 inch right here because this is the part that has to bear against the abutment as you're driving the wedge in. It's pretty self-explanatory. And then what I'll do is once I have everything shaped the way I want, I ran the walking gauge around here, and what I'll do is plane this flat. This hasn't been planed yet. I'll plane this flat, and then I'll take a good length on it and cut all the decorative bevels on it, so it'll be done. But right now, just for test fitting purposes, I like to leave it long so I have a place to clamp it when I'm doing all the shaving and stuff and adjusting all this. I'm clamping it back here, and I'll cut all this and trim it later. So far so good. This is going to be a nice plane. And I'm real happy with not having to do a plane with a chip breaker. It's not really necessary, so this just proves my point. So I'm going to just keep going with everything and check back in and film some more stuff as I see fit. First copy is pretty much done. So I did some work on the wedge, cut the final angle on the top, and then when I was test fitting the blade and doing all that preliminary work, I noticed that the hammer was damaging the end of the wedge. So I came up with the idea of laminating a piece of solid brass onto the end. What I did was I drilled 6 holes into this piece of brass. I don't know if you could see, but there's the footprint. I took 1/8 brass rod and I brazed it into the holes, and I left little stumps. I took a photograph of it, and then what I did was I laid out holes in the end of the wedge, and I inserted the studs that are brazed to this plate into the holes, and I epoxied everything, and then I trimmed it all up, and I put the little decorative bevels on it so you can see how that looks. Come in real nice. I balanced them, squared them up, broke all these edges, rolled these edges a little bit. This is going to take some nice wear. I wouldn't bash the heck out of it with a hammer, but it looks pretty cool, and I think it's going to just extend the life of this a little bit. This is probably going to be more of like an ornamental plane than anything else. It's probably not going to get like heavy duty daily use. So I'm not too concerned about it lasting for like the next 300 years. But this is going to be fun to work with. So the other thing that I did, which I won't show you, but what I did was I took a piece of cardboard from a pizza box, and I put it between the bed and the blade, and I moved the blade forward just a little bit and tightened up this clearance area right at the front of the blade. And it does two things. It makes the cut a little bit smoother, and also what happens is it sort of it works as like a gasket, and it levels out the I'll show you here. It kind of like levels out it levels out the relationship between the blade and the bed of the plane, and then the wedge basically compresses it. It's like a gasket. It's like a shock absorber, but you can't compress the cardboard that much. So just that little bit that's in there locks it all together, and by moving the blade this way about 1/16 of an inch or maybe even less, I tighten up the throat. So it's doing several things at one time, but this wedge fits really well. I got the abutments. I think this is the one where the abutments and the wedge, if you can see it, it just came right out of the saw. All my hand work in here worked out really well. I think there was the other one that had to be tuned a little bit, but this one came out real nice. I'm at the end of this project. I put the Thompson's water seal on the two copies. Everything is sanded to 220. There were several things that I learned from this process. On the back end here, on the original, this is very slender, and the back end of this plane tapers more drastically than I imagined, because when I was shaping the copies, I rounded this area, and they are still more rounded than the original, but the more slender the plane is back here, and the more rounded this area is, the more comfortable it's going to be to hold. I reshaped the back end of the two copies 3 times. This is the third time. This is the third version of my back end of both the planes, because it was just uncomfortable to hold. And so what I realized was that I was just hesitant to remove too much wood, but every time I picked it up, I didn't like it. And as I started to really compare it to the back end of the original, I realized that it had to be real small for your hand to fit around it. And this is still heavier than the original. It's fine, I can hold it, but that's just a heads up to anybody that might want to copy this. The other thing that I'm finding out, I did make one plane beforehand without a chip breaker, but this one right in here without the chip breaker is working way better than I expected. Also, I added cardboard to the beds on both planes and tightened up the mouth just by a little bit. But the cardboard is doing two things. It's locking up the blade against the wedge really, really well, and it's reducing the chatter, and it's reducing the opening to the throat. So if anybody's making planes by hand and you want to go ahead and just throw a very thin piece of cardboard in there to do it, don't be afraid to do that. It's going to help you a lot. But I would say tune the wedge and tune the buttresses before you do any of that. You want it to work almost 100% without the cardboard before you add the cardboard, and then it's going to make it like it's night and day. And what I'm finding is you don't need chip breakers. It's a waste of time, and actually makes this plane a heck of a lot easier to make, and it's performing fine. Just use your own blade. You want to use your own blade with a chip breaker, that's fine. I never even got into that. The other thing that I never filmed was me heat treating this. I had some film footage of myself using torches to heat treat the end. I wasn't happy with the way the blade came out. I have some fireproof bricks. I made a little heat-proof enclosure with a few bricks, set up some torches that I didn't have to hold by hand, heated the heck out of the end of the blade. I did the whole job over again. I got a lot of heat on it. The thing was red hot coming back, I'm going to say 2 inches from the end. And I dunked it. There was a heck of a lot of smoke from the canola oil that I used, but I got what I wanted. I rehomed the blades. I put a 2-degree micro bevel on it with the 1200 grit stone. They're fine. I never bothered to dress up the corners of the blade because they're starting to get bashed up as I'm using them just to do the testing. They're already scarred up, so dolling them up is a waste of time. So I skipped that whole thing. So these are going to be usable planes. In fact, I got a piece of maple set up right now. Let me just go ahead and move the camera, and I'm gonna take away my original from the workbench and pick up one of the copies, and let's see, just give this thing a shot. I tuned them up pretty well. One of them gives a slightly heavier cut than the other one. Let's see, this one is the this one's giving just a whisker. It's fine. For a homemade blade and a homemade plane, that's fine. I'm not going to ask this plane to do anything more than that. Now, one other thing I may have mentioned, but I'll mention again, is whatever wood you use, if you're making any planes at all at home, has to be well dried. The stock that you use has to be well dried because you don't want any shrinking. And what I found on the original, and I'm going to guess, now this is just guessing because this was made generations ago, but you have plenty of shrinking in here. So there's only 2 reasons why that would happen. One is the way it was stored. The other is because, and this is the most likely reason why you have shrinkage. The most likely reason why is because this wood was not properly dried. It was not dried long enough before they made this plane. Now, I had the luxury of waiting 5 years from the time I milled this wood until the time I made this plane. 5 years. Okay? This is pretty dry, and it's been stored indoors the whole time. Dollars to donut. This wasn't. This was made by a plane maker Oh, by the way, I never gave the maker of this. This is a, let me see, I get the M. Copeland, warranted. And I'm not sure who made the blade. Might have been the same manufacturer. Anyway, this is an M. Copeland plane. M. Copeland was in business to make planes. And when he got a delivery of wood, I don't know how long they let the stock stay around before they started making planes. And this might not have cracked until 25 or 50 years after it was made. And by then, nobody cared. But if you want something that's going to last, if you're a young woodworker and you make a plane and you want it to last the rest of your life and the rest of your future children's and grandchildren's lives, start off with something that's dry. Use the best grain that you can, and you're going to make yourself something nice. And it's not that difficult. I showed almost every step. I gave you pointers on what to look for and things that you have to pay attention to. So here you go.